Hi everyone, Miss Tui here. In today's lesson, you are going to use your Ozobot and program it to show cool moves and sound effects to determine if fractions are equivalent or non-equivalent. You will look at a fraction model to write in the numerator or the number of parts. Then you will program your Ozobot to determine if the fractions are equivalent or non-equivalent. For today's lesson, you will need an Ozobot, fully charged and calibrated, your color-coded markers, a pencil, and your fraction equivalence practice pages. Make sure you have both pages. After today's lesson, you will be able to look at a fraction model to find the missing numerators. You will also be able to compare two fractions to see if they are equivalent or not. Before we jump in, let's review some important vocabulary used in this lesson. A fraction is a number that describes equal parts of a whole. A fraction is made up of two numbers. The number on top is called the numerator, and it tells you the number of parts. The number on bottom is called the denominator, and it tells you the total number or the whole. Thinking about pizza is a great way to better understand fractions. If I ate 1/4 of a pizza, that means there are 4 equal slices and I ate one of them. Equivalent fractions are fractions that have different numbers but the same value or amount. Using fraction models are a helpful way to see how fractions can have different numbers but still be the same value or amount. Let's think back to that pizza. Here's my pizza with 4 equal parts. Remember, I ate one of those parts. Now let's look at a pizza that is the same size, but this time it has 8 equal parts or slices. How many slices or parts would I have to eat to be the same as 1/4? That's right, I would have to eat 2/8 to equal the same amount as the 1/4. 1/4 and 2/8 are equivalent fractions. Although the parts are different sizes, the overall amount is the same. Time for the fun to begin. You will need your fraction equivalence practice pages. Each pair of fractions have a path between them. Let's find the first pair of fractions to look at and compare together. The fraction on the left side of the path is already named, but the fraction on the right side of the path is missing the top number, or the numerator. The fraction on the left side says 1/2 and shows a fraction model to match. The fraction on the right side shows a different fraction model with an incomplete name. Your task is to complete the name of the fraction by identifying the number of shaded parts. When you look at the fraction model, you'll see 4 equal parts. The number 4 has already been written as the denominator for you. How many parts are shaded? That's right, there are 2 parts shaded. So you will write the number 2 as the numerator to complete the fraction 2/4 for the fraction model. Can you write the numerator to complete the name of the second fraction in the pair? Now that you know the names of both fractions, you will use the names and the fraction models to compare the pair. For the first example, the fraction on the left is 1/2 and the fraction on the right is 2/4. Look at the two fraction models. Are the shaded parts equal? Meaning, do they show the same amount, or are the shaded parts unequal? Meaning one shows more and one shows less. Way to go! These two fractions, 1/2 and 2/4, show the same amount, so these fractions are equivalent. Although the parts are different sizes, the overall amount is the same. A way to check your comparison is to make a real-life connection. So let's think about some more food, but this time our fraction is about a sweet treat like cake. You could either eat 1/2 of the cake or 2/4 of the cake because they are equal amounts. Now get out your color code markers. After you've compared the fractions, it's time to code. Look at the color code key at the top of your paper. The key tells you what color codes to use if your fractions are equivalent or not equivalent. Since you determined the first pair of fractions, 1/2 and 2/4, are equivalent or equal, you will use the color code spin and play again to complete your path for the Ozobot. Remember to color the empty boxes following the same sequence or order as shown in the key, just like I am. Can you use your markers to draw spin and play again color codes to complete the first pathway on your paper? Are you ready to see your bot in action? I know I am. Let's watch to see what the bot does when I place it on start. Since 1/2 and 2/4 are equivalent fractions, Ozobot will spin and celebrate. Does your Ozobot spin and celebrate to show that 1/2 and 2/4 are equivalent fractions? Great work comparing your first pair of fractions and programming Ozobot to demonstrate it. Now you will continue the activity comparing more fractions on your own. You can do it. Remember that a pair of fractions can be equivalent or equal, or a pair of fractions can be non-equivalent or not equal. The color codes you put on your path should match the comparison. In the first example, the fractions 1/2 and 2/4 were equivalent, so you added the color code spin and play again to program your bot to celebrate. If you find a pair of fractions that are non-equivalent, you will use the color code zigzag and game over to show your bot shaking its head and disappointed. Can you compare 5 more pairs of fractions and program Ozobot to show if they are equivalent or not? Before turning in your work, make sure you have completed any missing numerators, drawn color codes on each path, and programmed your Ozobot to show if pairs of fractions are equivalent or not. If you're looking for more fun, create and name your own pairs of fraction models to compare.